Assalamu alaikum, my dear students. How are you? Hope you will be fine and okay. I welcome you all into my today class. And today is the beginning of our new unit, Unit 19. It is lecture 50th, and the unit is Atomic Spectra, and I'm your teacher, Muhammad Ikram. The we will start with the topic X-rays, but this is very unfortunate that we are starting right from the middle of the chapter instead of the beginning. And you know that because of the COVID-19, much of the syllabus has been reduced in this chapter, but still I wouldn't keep quiet or silent on the introduction to this chapter, and I would like to give a very brief introduction to this one, that what it really means. So the atomic spectra, let me introduce it to you. The atomic spectra, that what really the atomic spectra means. Atomic spectra is in fact the spectrum of frequencies, the spectrum of frequencies, the spectrum of frequencies of EM radiation. You already know what I use EM for. The EM radiation, the EM radiation emitted by the EM radiation emitted or absorbed. Emission is not all that necessary. Emitted or absorbed during the transition of electron, during the transition of electron or electrons between energy level, between energy level. This is called spectrum, and the process of analyzing spectrum is called spectroscopy. This is called spectroscopy, right? To analyze the spectrum. Now, why is it important? That it's important is that we use the spectrum, or rather I would like to tell you that, long story short, spectrum is in fact the fingerprints of an element. Fingerprints of an element. This is what my favorite sentence for it. Of the elements, the fingerprints of the elements. Why? Because no two elements have the same spectra. No two elements have the same spectra, have the same spectra. It is different for different element. Here you see the visible spectrum. Here you see for look the hydrogen. Look, this is a visible spectrum. Here you see it for the hydrogen, for the neon, and for the iron. And you see that all this is just like a barcode for an item at the grocery shop. So you see that no two item have the same barcode. Similarly, here you see that no two elements have the same atomic spectra. So atomic spectra play a very wonderful or an important role in the identification of the elements wherever they are. Okay, so this is one of the most important features of the atomic spectra. There are absorption spectra, emission spectra, band spectra, molecular spectra, but we are not going to discuss. This is just a very brief introduction to the atomic spectra is. Now, let us start with our topic, the X-rays. Now, what are X-rays? X-rays are I would like to tell you that X-rays are the let me write here. Then later on, let me introduce it to you first. Okay, fine, no problem. X-rays were discovered in 1895 by the German physicist William Rattingen, and this was a remarkable invention. And this is why that he got the Nobel Prize for his this invention in 1901. This is so remarkable that today you cannot consider even the smallest and the simple of a clinic without x-rays. So the use of the x-rays, the uses or the application of the x-rays are manifold. They from the field of medical sciences into industry, right? X-rays, what are x-rays? X-rays are the EM radiation. They are what? They are the electromagnetic waves, the electromagnetic waves of very short wavelength, Yeah, you can say that high energy EM waves, and they are usually monochromatic, right? So the electromagnetic waves are the X-rays. They because they were called the X-rays in the beginning or at the start, their nature were unknown. Okay, they were invisible and their other characteristic were unknown, right? For example, I would like to tell you that X-rays cannot be deflected by the the electric field or the magnetic field, right? So there were the characteristics which were unknown in the beginning. Therefore, these kind of rays were termed as X-rays. But the only thing which were known that when you place your hands in front of the X-rays, you would see the shadow of your hand at the back, right? So these are the X-rays. Few important things: the wavelength of the X-rays are of the order of it is of the order of 10 raised to the power minus 12 to 10 raised to the power minus 9 meter, right? And the energy of the EM waves are of the order of, it's it is from 124 electron volt to 124 electron volt to 124 kilo electron volt. So they are different than the ordinary light waves because their energies are within the range of electron volt, while the X-rays have energies within the range of the kilo electron volt, right? So these are the X-rays. Now, how the X-rays are produced, the production of the X-rays, I will discuss with you. Production of X-rays. For the production of the X-rays, the X-rays are produced by two kind of principles or two mechanisms. Two principles are mechanism are important in the explanation of the uh, production of the X-rays. One we call the Bremsstrahlung radiation. Yeah, Bremsstrahlung process, or sometimes they are also called the braking radiation. The braking radiation, I will explain to you all these one by one. And the second important is known as the characteristic X-rays. So the characteristic X-rays. So these are the two important features which are capable of explaining the mechanism of the production of the X-rays. So we will discuss them one by one. First of all, I would like to tell you something about the apparatus which is used in this experiment, in the production of the X-ray series. There is the X-ray tube, the X-ray tube. The X-ray tube, here you see that, look, this is the X-ray tube. Inside the X-ray tube, here you see that the tungsten filament. Here you see the copper anode, and here you see, look, this one, this portion. Let me make it shaded for you. This is known as the tungsten target, and here the copper, which you see here, the copper anode, and it is connected with the high voltage source. And here you see the tungsten filament, and this is connected with the low potential difference source. Here, if I just make this negative terminal, and with this is the positive terminal, right? And maybe I think a 6-volt battery or for 0.3 ampere of current, this is used to heat the filament, right? And then the entire assembly is enclosed or encased in the evacuated glass seal or glass tube. Here you see. So let me tell you, this is here. This X-ray tube, it is filled with vacuum, that all the air is removed from it, filled with vacuum. Now, as I told you that the working principle is based on the Bremsstrahlung radiation, usually accelerated charge, but this is the very simple working principle here is that whenever charges are accelerated, EM waves are produced in that region. Whenever charges are accelerated, EM waves are produced. One is this thing, and we can also say that EM waves, electromagnetic waves, or these X-rays waves, are produced during the transition of electron or electrons between various energy level, These two processes will help us produce the electromagnetic radiation. Now here, this field, as I told, that there is filled, that the X-ray tube is filled with vacuum. I told you about the cathode also, and I told that the cathode is in fact what? A tungsten filament. Right? This, when heated, this produced what? Reduces electron beam when heated by the process of what? by the process of thermionic emission, which I already discussed with you in the previous chapter. as well as you have learned about the thermionic emission in the class 10th also, that whenever a metal surface is heated, then there produced what? Then there produces electrons. Yeah, that is when a metal surface is heated, electrons are escape from the metal surface. This is very simple. So this process is known as thermionic emission. Second important point here which I want to tell you, that for that is that the more electrons are emitted, that is more electrons on high temperature, more electrons are emitted when the temperature of the filament is increased, when the temperature of the filament is increased. When it is increased, then more electrons are heated, more electrons are emitted. Another important point, beside the cathode, there is anode also. The anode. Anode is also the anode here. You see that the anode is also what? The tungsten target. The tungsten target. This is our anode, which is surrounded by the copper, by the copper, right? Or the entire, that is, you can say that the assembly of tungsten target and copper. Copper is good conductor, but unlike the tungsten, it has low melting point. So you know that when it is heated upon the striking of the electron, then when it is heated, so it's the copper may quickly heat up rather than the tungsten target. This is why we use the tungsten as the anode. Okay. So it will serve as an anode. And another important point here, which I want to tell you, is this one, that here one electron corresponds to one photon. One electron would cause one X-ray photon. One X-ray photon to emit. So this is so beautiful that X-rays are in fact this process. The process of the X-ray is nothing but it is just the reverse of what? Photoelectric effect. The reverse of photoelectric effect. Electric effect. What you see in the photoelectric effect, when photon strikes a metal surface, electrons are emitted. Here the reverse happens in the X-rays. When electron strikes the metal surface, photons are emitted. What? That is when the beam of electrons, hit the metal surface, hit the anode, I would like, hit the anode, photons, X-ray photons, X-rays photon are emitted. X-rays photons are emitted. X-rays photons are emitted. And this is what I told you, right? Now here, I just want to explain these two processes or these mechanisms. Here you see, look, the X-rays are being produced. You place your hand in the path of the X-rays, and here you see your image on the film or on the screen, that is of your hand. So now let us see that what is going to happen. Let me explain you that how this has been done. Let us first, I would write that which mechanism I'm going to explain to you. The first mechanism is that of the Bremsstrahlung radiation. The first mechanism by which the X-rays are produced, that is known as the Bremsstrahlung radiation, or that are called the braking radiation. This is what the deceleration in this process. X-rays are produced. X-rays are produced. X-rays are produced by the deceleration of the deceleration by the deceleration by the deceleration of high speed electrons of high speed high speed electrons as they enter they enter the electric field of the nucleus, as they enter the electric field of the nucleus. So this is a German term. Brems means the braking, and Strahling means radiation. So this is why they are called the braking radiation. That is, the result is deflection. The electron beam deflect and cause the electron beam deflect and cause to emit X-rays, to emit and cause the emission of X-rays, cause the emission of the X-rays. Now let us see here. Look, let me explain to you here that what is going to happen. Now, as you know that when the current flows through the filament is then heated. The filament is what? The filament is heated. So look, this is thermal radiation. The filament is heated. When the filament is heated, then electrons are being escaped from the metal surface, since the anode is kept at a very high potential, as you see here. So what is going to happen upon arriving the target, right? When they arrive on the target, the anode is kept at a very high potential. Then what happens? Electrons being moving towards the anode, as you see here. Now look what happens in this case, in the Bremsstrahlung radiation, the braking radiation. Here what you see, look, this is the target nucleus, the target atom or nucleus. Now you see that, look, for example, if the fast beam of the electron comes, like for example, if there is an electron coming, right? If the electron make its way towards the nucleus, because since as compared to the electron, the nucleus for a high charge, the electric field is what? The electric field is very, very strong. This is the nucleus. Now what happens? Let me explain to you or tell you that, look, here I choose an electron. As the electrons comes, for example, let us see that this is the path of the electrons being, let me do it in this way. See here, for example, look, if there is the electron and if the electron comes, this is the path of the electron. As the electrons arrive, then the field of the electron right here, the field of what? The field of the electron interact with the field of what? With the field of the nucleus. And what happens, since electron have negative charge on them and it has a positive charge on them, and it deviates from its path, you see that the change of path is also acceleration. And you have already learned in the previous chapter that accelerated charges always produce electromagnetic radiation within that locality. So this is how the gamma ray photon is being emitted, as you see here. Look, this is what this is. The sorry, not, very sorry, the X-ray photon. I'm so sorry, not the gamma ray photon. So here you see the X-ray photon is being emitted here, like as you see. Now look, if you see, look at the graph, much of the electrons are decelerated by the nucleus. So here you see, look the graph for the look at the graph for the Bremsstrahlung radiation. Look at the relative intensity as you see here. Look, as the energy increases, what happens? The relative intensity increases, and as you see, log. So this is just here you see that much of the portion here, this graph or this portion is from Bremsstrahlung radiation. This is from Bremsstrahlung radiation, and this portion. So you see that it includes simultaneously both the processes, where you see the very high peak intensity of the emitted X-rays. This is called the characteristic radiation, right? And this is different for different element, because it is, they are called the characteristic radiation because they depends on the nature of the target element, nature of the target element, and it depends that the transition is from which level to which level, right? So it all depends on this. So this is how the X-rays being produced. Another process which we call the characteristic X-rays. For the characteristic X-rays, let me tell you that what is going to happen for the characteristic X-rays. Characteristics X-rays. That what are the characteristic X-rays? Characteristic X-rays is the X-rays, the X-rays which are produced, the X-rays which are produced due to the transition, due to the transition of electrons from one energy level, from one energy level to another energy level. Now, how this can be done? This is also the kind of process I would refer to as the process of what? This is what you can say, the process of ionization. Ionization, this seems to be very strange for you. The process of ionization here. What does ionization means? The removal of electrons, right? So here this thing also happens, but how? This is here, how electron can ionize an atom or another electron. This is very simple, by the process of what? By the process. This is done by the process of Coulomb interaction. Coulomb interaction. But here the Coulomb interaction, yeah, by the process of Coulomb interaction, better to write the process of Coulomb repulsion. Here this happens, this ionization process happens because of what? Because of the process of what? Because of the process of Coulomb repulsion, that there is a Coulomb repulsion. Okay, and they are called the characteristic X-rays because distinctive It is because distinctive for the particular element, for a particular, as I told you earlier, particular element means that Z dependence, Z dependence. Okay, so here you see that look how the transition of the X-rays occur here. Now look that what is going to happen for this. I'm sorry, there is no diagram here for the characteristic X-rays, but let me do it right over here. Let me tell you. Look, you see that the for the same portion of the diagram, I would like to tell, for example, that if there is an electron, look, this is what, that if there is electron coming with its very high energy electron, as you this is, see here. Now look, as for example, this, let's see that electron is being coming. Okay, this one I am not selecting this. Now here, that is for the Bremsstrahlung radiation. Okay, the pink color is for the characteristic X-rays. As you see, look, what is going to happen is the electrons arrive right here at this point. Then now you see that, look, what is going to happen? That either there might be a head-on collision, right, or there might be what, Coulomb repulsion. So you see that it has a negative charge on them, this has a negative charge on them, and this has also a negative charge on them. So there is a Coulomb repulsion, and what happens that the electron speed is so high here, so it has so greater energy that what happens, this electron is raised to a higher energy state. Look, it leaves this and then come here, for example. Now you know that this cannot be remain empty, and what will happen, that there will be a downward transition to occupy this space again, so electron would come. Since it is the lowest energy orbit, so the extra energy which the electron has, it will emit that energy, and that energy will be in the form of gamma ray photon. And once there is a transition, then what will happen, there will be a gamma ray photon, sorry, I'm so sorry, X-ray photon. Then there will be what, X-ray photon will be emitted. So this is all about the X-rays. X-rays has a lot of applications in our daily life, beside the one, the medical application which I told, that to find the fractures in the bones or any other abnormalities in the bodies. So that is the that is we use this is why we use X-rays in the field of medical sciences. There are a lot of application there in industry and for the security checkup. For example, look at your baggage as they pass through the security checkpoint. Here you see, so with the help of the X-rays, they can identify that what is there in your briefcase. For example, here you see the glasses, here you see the headphones and your smartphone or like that, so they all can be detected. So this is why you always see it installed at the security checkpoint in airports or at the bus stations or where the public life has to be taken care of. So this is how they are using the X-rays. There are a lot of application. For example, X-rays can be also used to detect the cracks, right, just like in a tennis ball. So at least in every field of life we use the X-rays. One important point which I would like to tell you, one bigger drawback, and I want to place it right on the top, and that is that X-rays, look, this process of the production of X-rays, right, this process produce 1%, that is 1% X-rays. Through this process we produce 1% of X-rays. and 99% heat, right? This is why that here, as I told, that the copper is good conductor of heat, so it extract heat from the tungsten filament. This can be done by various ways also, and then it is cooled by using oil of very high specific heat. They remove the heat from the tungsten filament so that burning could be avoided. Okay, so through this process, that the electrons, upon hitting the target, much of the electrons do not cause the production of the X-rays, and they just produce excessive heat. So this is one of the disadvantage, that here you would see the 99% heat while 1% X-rays only. So this is the end of our today lecture. Thank you very much for being here. See you in the next lecture, inshallah.